The first ever satellite launch was a worldwide sensation, to say the least. It took place in 1957, sending the metal sphere with its antennas on a journey above our planet and giving radio enthusiasts their first signal transmission from space. The spacecraft launched by the Soviet Union was quite basic, hence its name, PS-1, primary satellite. Satellites have come an incredibly long way since. Even those in the same weight class as PS-1 are far more complex. A state-of-the-art satellite is much more than just a flying radio transmitter. It transmits massive arrays of data, bringing us online communication, high-definition TV, photo and video recording, making it possible to observe distant stars and galaxies, and so much more. The satellite's structure and design depend on its mission requirements and orbit altitude. Based on its size and mass, a satellite may be defined as one of the three types: small, medium or large. Clearly, the satellite's size does dictate its design to an extent. In general, however, all satellites are made up of two parts: platform and payload. The platform is equipped with an onboard computer, solar arrays and various other systems allowing the satellite to operate successfully for many years. Upon the platform, the payload is installed. A satellite's payload is the very reason for its launch to space. It is what makes the spacecraft's mission possible, whether the mission is to transmit communication signals, provide coordinates and time tags for navigation, or take photos. The satellite is delivered into orbit by a special vehicle, the carrier rocket. On your daily commute, you don't necessarily know or care about the make of bus that takes you to your destination. The make of the carrier rocket, on the other hand, is defined early on when the satellite is being designed. Talk about VIP transport. That's the level of care that goes into ensuring the satellite is safe and capable of doing its job, serving people like you and I.